Alright, so for our next section we'll be talking about classifying triangles. And remember, the word classify means we're going to identify or group something together using a characteristic. So in classifying our triangles, we're going to group by angle measure and then also side length. So let's take a look. Classifying first by angle measure. A lot of this information will be review. But we can classify triangles by their angle measures. An equal angular triangle, for example, is a triangle with 3 congruent angles. So let's think about the prefix of this word. Equa comes from equal, and then angular is going to come from angle, so 3 equal angles. So if we look at our diagram here at right, we've got triangle A, B, C, and you'll notice each angle is 60 degrees. So we would say notationally that angle A is congruent to angle B is congruent to angle C. Therefore, triangle ABC is equal angular. Something else to note is that we recall that all triangles' angle measures sum to 180 degrees. And if you have 60 plus 60 plus 60, indeed that does equal 180. Here's our other 3 triangle classifications in our table here. We have acute triangles, acute meaning all angles are acute. So if we look at the angles here, 72, 50, and 58 degrees, indeed all 3 angles are acute. Recall that acute angles measure less than 90 degrees. Our right triangle here, we have 1 right angle, so that's given notationally here. So that means we've got 1 90-degree angle. And if you'll notice, the other 2 angles must be acute. So think about, again, how many degrees in one triangle? We've got 180. If 90 degrees are already taken, then that means that these 2 angles must also sum to that other 90 degrees. So 90 and then 90 does equal our 180 once again. And then for our obtuse triangle, we're looking for 1 obtuse angle. And that 1 obtuse angle here is the angle with 104 degrees. So recall that obtuse means angles that are greater than 90 but less than 180. So 104 degrees is our obtuse angle. So 4 classifications by angle measure. Equal angular, acute, right, and obtuse. Let's take a look at our example. And we can use the angle measures to classify this triangle JML. So first of all, let's identify what we see. Angle JKL is obtuse, and how do we know? It's because it's 120 degrees. So angle J, actually it should be LK here. JLK is 120. So the triangle JLK is an obtuse triangle. So make that adjustment here. This should be angle J and then L and then K here. Make that adjustment in your notes. So let's work through and actually kind of step by step solve this classification. So angle JLM and angle JLK form a linear pair, so they are supplementary. So let's take a look. JLM and then JLK, 2 angles that sit next to each other on a line, are supplementary linear pair. So if we look at their measures, we know that the measure of JLM plus the measure of angle JLK must sum to 180, and that's because that's the definition of supplementary angles. They sum to 180 degrees. So now let's say that the measure of angle JLM plus 120 is our 180. Well, how do we know? Substitution. So all we did was we took the measure of JLK and we dropped in 120 because that's what's given in our diagram. From here, we can then say that the measure of angle JLM equals 60 degrees. And how did we get to that answer? We just subtracted. So again, 180 minus this 120 would leave this angle 60 degrees. And so for our final answer here, to classify that triangle JML, we know that since all angles of JML triangle, JML, are congruent, then that triangle is equiangular. So again, we've got 60, 60, and 60 degrees here. So triangle JLM is equiangular. So at the bottom of this page, you're going to finish numbers 1 through 6 for homework. And then just pause and continue on in the video for the other side of the worksheet to classify by side length. So now we're looking at side length, and we're going to group triangles together with their sides. So let's take a look. We've got 3 classifications here. First one, equilateral. Again, you'll see this prefix equa, meaning equal, and then lateral means side. So notice you've got tick marks here, and from earlier in the semester we've learned that those tick marks mean congruence. So your 4, 4, and 4 side lengths also indicate all sides are congruent. So equilateral triangle. For isosceles triangle, you've got also tick marks here, at least 2 sides congruent. So you'll notice 2 bars for your tick marks, but that's still just representative that those 2 match these 2 here. So 8 and 8 for your side lengths. So at least 2 sides are congruent. So also let's think about, if the triangle is isosceles, could it also be equilateral? Or if the triangle is equilateral, would it also be isosceles? So we'll talk more about that in class, but be thinking about how the at least comes into play here. And then for our scalene triangle, scalene is where we have no sides congruent. So you'll notice that we've got 3 different side lengths, a 7, a 9, and an 11. So let's use the triangle here for our example and classify by side length. So first, take a look at what you're given. You've got tick marks here on each side, so you know that all sides are congruent, and that's going to help us in our setup. So let's take a look at step 1. We want to find the value of x. So when we want to find an actual side length, remember we want to use our variable x to try to get to a side length which is a number. So you want to solve until you get a numerical side length. So we know that segment length QR equals segment length RS. And again, our tick marks indicate that. So segment QR equals segment length of RS. And that's the definition of congruent segments, again indicated by that tick mark. So next we've got 4x equals 3x plus 5. And we got to this step by using substitution. So QR, if we substitute that with 4x, and then RS we substitute with 3x plus 5. Now we need to solve for x. If we subtract 3x from both sides, we end up with x equals 5, and that's our simplification, just moving like terms around. So to simplify, we have x equals 5. So now that's great. What are we going to do with it? Let's use substitution here to find the length of a side. So we've got our 4x equals 4 times 5, which is 20. So we substituted that 5 in for the x value for this one side length here. And just simplifying, we got our 20. And again, if all sides are congruent, then if that one side is 20, then all the other sides must be 20 as well. So each side length of triangle QRS is 20. So now you'll finish 7 through 11 on the bottom of this page. Bring both sides completed for your homework for next time.